2011, day 1, question 2. Simplify fully. So looking for anything common in here. I can see there's an AB squared term, and there's an AB squared term here as well. So 3 lots take away 1 lot is 2 lots, plus 2a squared b. We could factorise that, it doesn't ask us to, so we'll leave it like that. Simplifying, 4's into that go 1, 4's into that go twice. One of those x's will cancel one of those, so I'm left with 2x, or 2 over 1. Part B, expand and simplify. You could pause it, try it, see if you can get the same answer, see if you agree. No mistakes. Right, part C. Right, the formula for the radius r in terms of the other variables. So we want to rearrange this formula. Lots of ways we can do it. The first thing I might do is actually multiply both sides by 3, or 3 over 1, because then we can just cancel that 3 and that 3. So 3v will be pi r squared h. We're wanting r on its own, we need to divide by a pi and a h. What do to one side, do to the other. Lastly, r will equal the square root of 3v over pi h. We only want the positive square root because a radius, of course, can't have a negative answer. Part 2, same volume. One cone is twice the height of the other. So if we make this one h, this one is twice the height, would be 2h. Expression for the radius r of the shorter cone in terms of big R, so we want to end up with little r equals. We know they have the same volume, so the volume of the large must equal the volume of the small. Volume of a cone from the previous question, pi over 3 times r squared times h. So if we're doing the large one, r is capital R, 3 times r squared times the height, which is 2h. Volume of the small one, pi over 3 times the radius times the height. Now we're just going to look back because I think, no, that's right, pi over 3 r squared h. Pi over 3 r squared h. Right, once again, perhaps multiplying by 3 both sides will eliminate the fraction. We want little r equals, so we'll divide by the pi and the h, which means r equals, now on this side we're going to have a 2r squared, and that's all. So we've got an expression for r in terms of big R. But we've forgotten the little squared there, haven't we? So there's a little squared there, which would mean that r would be the square root of 2r squared. Now because it's multiplied, you can square root the 2 and square root the r separately. Obviously I don't know what the square root of 2 is, we'll leave it like that. However, the square root of r squared would just be capital R, which looks a lot nicer. Right, down to D. The sequence of numbers. Give the rule for finding the difference between any two consecutive terms from the sequence in its simplest form. Okay, so the bigger term will substitute n plus 1. everywhere there's an n. Would give us one term, and of course 3n squared minus 2n plus 1 would be the smaller term. We want to rule for the difference between the bigger term and the smaller term. Give a rule for finding the difference means subtraction, between any two consecutive terms. Right, there's a bit of expanding to do in here. Now we need to do n plus 1 squared, so somewhere we need to expand that. Plus 1n plus 1n is plus 2n plus 1. So we'll go back up and we'll put it in here. Now I've got minus 2n, minus 2 plus 1. Expanding with the 3, 3n squared plus 6n plus 3. We might expand the minus into it now, so we'll get minus 3n squared. Subtracting a negative, or minusing a minus, two minuses, we'll make that plus 2n, and then we'll get minus 1. Right, so let's have a look in here. 3n squared, now I've got 6n minus 2n. 3 take away 2 is 1, 1 plus 1 is 2. So simplifying that, 3n squared minus 3n squared, that will disappear. 4n plus 2n is 6n. 2 take away 1 is 1, 6n plus 1. So that's what the difference, oops, we lost that. That's what the difference between any two consecutive terms would equal. There's more we could do on that, but that will do.